Hi, so welcome to Erosion, Module 3 of Land Rehabilitation, EART3339. So in this module we're going to cover erosion. So when is erosion a problem, and basically what it is. So I'm going to give you a series of lectures describing what erosion is, some of the physical processes that are involved in erosion, and how to manage erosion, some things about erosion modelling. And then we're going to finish up with some concepts around ecohydrology and ecogeomorphology, understanding the relationships between plants and the landscape. Sorry, that's my phone going off. Decline that. Okay, so when is erosion a problem? Well, soil, usually we're interested in the erosion of soil, not necessarily rocks and things like that. So soil comes from somewhere, and usually it comes from the weathering of bedrock. So we have a production of soil from the bedrock at a certain rate, and we get removal of the soil at a certain rate for erosion. And essentially, erosion becomes a problem when our weathering rate can't keep up with our erosion rate and we lose our soil, or we get soil degradation. Erosion can also be a problem if, for example, it changes soil properties and then we can't utilise that land to grow crops or put plants back on post-mining landscapes. So essentially we have a bunch of things that lead to the loss of materials from a hill slope. Some of the material can be dissolved and go into solution. So that's that little D term in the figure there, dissolution of soil and rock minerals. And that's just stuff that moves from the solid phase into the dissolved phase, into the water, and then moves away from the hill slope and is lost. Then we have transport down slope, and that's erosion. And a bunch of different processes, different types of processes lead to the transport of material down the slope, and we'll describe some of those. And then there's the weathering rate. So that's the production of soil materials from bedrock. So the lowering of the Earth's surface is generally caused by a number of factors. In humid climates, the mass lost in solution, for example, we can lose about 10 to 100 micrometers per year by the loss of materials in solution. That's a tiny amount, right? So erosion, the transport of material down the slope, is potentially going to be a much more relevant process, a much more quick process of losing material from the hill slope. So what little things cause erosion? Well, the very first thing that can mobilise sediments from the soil surface is rain splash, and here's a figure that shows exactly that. It's an image that was captured just after the impact of a raindrop, and you can see those soil particles being ejected up into the air. But notice that it's in all kinds of different directions, right? It's to the left, to the right, forward and backwards. And rain splash has a particular influence on the shape of hills, and we'll get to some of that later on. So we'll cover aspects of rainfall variability and how that impacts erosion, but essentially raindrop impact mobilises sediments because the raindrop has a certain mass. It impacts the soil surface at a relatively high velocity because it's fallen from the clouds. So that mass and energy that the raindrop is carrying as it falls is transferred into the soil, and then that energy can be transferred to the soil particles to move them. So these dot points here suggest that 2/3 of the energy that a raindrop has is actually expended to form those impact craters, and then 1/3 is left over to form the spray, right, which is carrying the soil particles away. Some of that, to form the impact craters, it has to actually move the soil up into the rim of that crater. So there's still some soil movement associated with the formation of the crater. And thin films of water around soil particles, which are held there by capillary forces, actually increase the effect of that raindrop impact. So if we have particles that don't have those thin films, then the effect of raindrop impacts are not as high. And also, raindrop impact is going to mobilize particles that are no other or have weak forces holding it together, right? So things like sand, which have very weak interparticle bonding forces, are going to be mobilized much more easily than well-structured, finer materials such as clays and things, which have those positive, negative bonds to organic matter and all that sort of stuff, holding it all together. So here's a few pictures which show you the effect of a raindrop impact. We have a crater being deposited, a crater being created after a raindrop, some little depositional zone, and then a region a little bit further away where splash particles are being deposited. You can see the same sorts of pictures here on the right-hand side, right, with varying degrees of water on the soil surface. Now, if we have a slope, for example, we're going to have some particles after the raindrop impacts, they're going to be ejected up into the air, and then some particles are going to be deposited upslope of that. Some particles are going to be deposited downslope of that impact crater and to the sides and so on. So raindrops can actually mobilize particles upslope as well as downslope, right? Whereas a lot of the time we think of erosion as just moving particles downslope. And you can see that in this figure here. This is an experiment by Moseley where they looked at measuring how much soil particles were deposited upslope and downslope of an impact crater with varying slopes. So they had slopes completely flat, 0 degrees, 5, 10, 15 and 20 degree slopes. And that's what's shown on these lines here. And you can see that there's a little bit of material, right, being deposited upslope, more when it's flatter, and a little bit less when it's steeper. But you can see that when you increase the slope, then you get more being deposited on the downslope direction. So with a slope, there's still bias in which direction the sediment is being transported. Right, so after it rains, then essentially water can, if it's high enough intensity, pond on the surface and then move down slope. And then we have the potential for other erosion processes to take place. So we're going to talk now briefly about sheet erosion, rill erosion, and then the formation of gullies. So sheet erosion essentially occurs closer to the top of the hill, where we're just getting runoff being initiated and the water hasn't had a chance to necessarily concentrate into smaller areas. So we can think of that as being like a flat, planar area where water is ponded on the surface and running down as a sheet rather than in a concentrated little zone. So we get sheet erosion, and you can see a picture of that here, looking across a hill slope near the top. So it's fairly uniform loss of soil across the area. And when the water gains enough energy and starts to concentrate into localized areas, and the depth of that water can increase and the velocity of that water then increase, then we can get the formation of rills. And typically they're sort of less than 30 centimeters in depth. And rills occur where surface runoff begins to concentrate, right? Surface overland flow begins to concentrate. So a lot of the time we get rills beginning halfway up a hill and then progressively moving uphill and then downhill. And then once the rills concentrate enough water, they can turn into what's called a gully. And really the distinction between a rill and a gully is a little bit nebulous in terms of the physics, but it's sort of generally adopted from the agricultural sciences, where gullies are defined as being it's too deep for typical farm machinery to cross. Right? So gullies they actually form a drainage line where water is concentrated by the landscape at a large scale. It allows large amounts of water to move through those areas. And because the water is concentrated, it's in cutting through into the hill slope. And because of that, it actually propagates backwards up the hill. We get headward erosion back up the hill, and we also get slumping in at the sides, which causes those sheer, very sharp edges and very steep edges into the gully. So this is like a young river. This is the beginnings of a river, tributary joining up into a larger river further downstream.